Statistic or fact? Four storm shadows carrying a total of 1,800 kilograms in tandem warheads allegedly erased 3 critical units in Bryansk's explosive production chain. That's the fact. Here's the question. How does destroying a mixing unit, a casting line, and a finished fuel hangar ripple into fewer grad salvos and tighter Russian artillery discipline? In the next minutes, we'll connect each damaged component to a specific battlefield effect and show why the cost of the raid sits at roughly $4 million, while the strategic impact could approach $1 billion in lost capacity. Before we move on, please take a moment to subscribe to the channel and like the video. How does knocking out 3 rooms 600 kilometers from the trenches turn down the volume of grad rockets at the contact line? Start by mapping the factory like a simple assembly. The chemical kitchen, the mold room, and the pantry. Together they convert raw powders and binders into the packed fuel that drives 122mm rockets, and the solid stages that sit deeper in Russia's missile roster. Remove any one piece and the tempo wobbles. Hit all 3 and the rhythm stalls. The chemical kitchen is where the slurry is born. Workers blend binders, oxidizers, plasticizers, and stabilizers under heat, while a vacuum system pulls out bubbles and stray moisture. The control is tight because tiny contaminants seed cracks. Scaling that to another site isn't copy-paste. Every mixer bowl, impeller, and filter has its own history. The surfaces absorb trace chemicals. The room air has its own humidity curve. Switching recipes or moving to different mixers means new calibration runs, new solvent flushes, and new waste batches. While that happens, output dips hard, and the risk of a bad batch rises. A bad batch in solid propellant isn't just waste. It can threaten a facility's safety record and shut doors for inspections. Next, the mold room. Casting isn't ladling soup. The propellant slurry gets poured into motor cases, vibed to settle, and then cured for days in ovens with strict temperature ramps. If the cure runs too hot or cool by a few degrees, internal voids grow. If the schedule is rushed, grain integrity drops. Scrap rates spike, and whole lots fail. A destroyed casting hall isn't replaced by running nights elsewhere. Curing ovens are bottlenecks by design. Each oven hosts a limited number of cases for a fixed time. You can buy more mixers faster than you can qualify new cure ovens. Wire them with uniform heat zones, and prove repeatability across multiple batches. The pantry, finished fuel storage, bridges the cycle. Those shelves hold completed propellant brains ready to mate with rocket bodies on separate lines. That buffer feeds grad 122mm rockets, other MLRS calibers, and selected solid stages in longer-range families. When the pantry disappears, lines downstream don't slow, they idle. Crews still show up, conveyors still hum, but they wait for certified grains that aren't there. Even a small hit to buffer stock multiplies into missed rail shipments and rationed allocations. Quality assurance rules this world. Solid propellant doesn't leave the floor without non-destructive checks. X-ray or ultrasound hunts for voids and delaminations. Samples go to tensile stands to verify strength and elongation. Every line that passes these checks is qualified for specific formulas and motor sizes. If a qualified line goes dark, new lines can't simply pick up the recipe. They must run trial batches, pass NDT scans, survive hot fire tests, and log consistent results. That requalification cycle takes months, not weeks. During that window, output for certified munitions remains capped. People ask why Russia's reserves and redundant plants don't erase this pain. Stockpiles help, but transport is a choke point. Moving oxidizers or filled motors across regions requires permits, escorts, and monitored temperatures. Prolonged storage demands controlled humidity. Detours and delays stack up at each checkpoint. Logistics officers don't gamble with cargo that can spoil or destabilize. The safest option is slower, and slower means fewer rockets at the front. This is why the strike bites. Machines can be replaced quickly. A validated process cannot. When the kitchen, mold room, and pantry vanish in one night, units on the line get fewer rounds. Commanders enforce stricter fire discipline, and replenishment cycles stretch out. The cost ledger tells the story. A few high-end missiles delete months of certified capacity. With the bottleneck exposed, the next question is how Ukrainian crews reached a node guarded by layered air defenses without losing the strike package on approach. So why gamble a crude jet and premium missiles when drones are cheaper by the dozen? Because the target wasn't a shed. It was reinforced industrial space with heat-treated walls, blast baffles, and certified machinery. You don't bruise that kind of node. You core it. 2 Su-24s lifted, stayed inside Ukrainian airspace, and sent 4 Storm Shadows on terrain-hugging routes at 30 to 60 meters. Ahead of them, 2 small, low RCS electronic warfare drones dragged a haze over the map, throwing off ranges and angles, generating clutter that looked harmless until the real weapons were already skimming treetops. The mission stack ran like layers of a single system. The aircraft only had to get the missiles clean of the rails. The EW drones kept radars second-guessing returns. The missile's guidance handled the rest, flying contour lines to stay below most search radars and using precision navigation to find specific halls inside a sprawling complex. That altitude band matters. Too high and they glow on screens. Too low and they risk power lines and terrain spikes. The chosen window threaded coverage while maintaining speed and accuracy. Russia's integrated air defense didn't sleep. S-400 batteries and overlapping sensors built a net that should have forced the missiles up or burned them down. One 5V-55 lock-on brushed the Su-24's envelope and pushed the crew into a hard break. Flares went, chaff went, and the pilot knifed toward ground clutter while the onboard jammer widened the fuzz. The track wobbled, lost enough quality to time out, and the crew lived by meters. That wasn't luck. The EW bubble and terrain masked the return just long enough to close the launch sequence. Storm Shadow fit this job for a reason. Its broach tandem warhead weighs around 450 kilograms and opens hard targets in 2 acts. A precursor to punch, a main charge to finish. The missile's low radar cross-section and guidance package were built to hit high-value nodes deep behind lines. It doesn't need a swarm to guarantee penetration. It needs a narrow window and the right aim points. Cheaper drones stumble here. Their payloads won't reliably crack thick-walled mixer suites or casting halls. Their circular error probabilities spread hits across roofs without certainty on the core machinery. They're also vulnerable near critical sites where jamming and short-range guns stack up. You could throw more at the problem, but you'd risk a pile of dents and scorch marks with the plant still breathing. The opening came from saturation. Ukraine flooded 8 regions with mixed decoys and legacy missiles from multiple vectors and heights, pushing command and control to triage returns. Operators had to pick which tracks mattered as the board lit with noise. That overload shaved attention and interceptor availability at the moment the Storm Shadows crossed key radar fans. It wasn't random. It was scheduled chaos to bend the net. One missile speared the mixing suite first to stop new batches. The next hit the finished fuel hangar to erase the buffer. A third followed into the casting unit to block a rapid restart. Sequencing mattered because the aim was to delete capacity, not just cause a fire. The result looked like 3 holes, but it erased qualified throughput. The price tag sat near $4 million. The return was time. Weeks to months of forced requalification, rerouted logistics, and rationed salvos while operators check every process step twice. With the corridor opened and the nodes cut, the front doesn't just sound different. Commanders now count rockets before they speak. Watch how battery chiefs schedule salvos at dawn and dusk, how pause lengths grow between volleys, and how official channels frame economy of fire as doctrine rather than a warning. Precision against certified production nodes moves more firepower than trading meters in trenches. Logistics sets the pace. A $4 million strike that erases $1 billion in capacity reshapes choices at every battery, not just on one map square. Watch the tempo. Count the pauses between salvos, the smaller barrages at dawn and dusk, the mentions of economy of fire. Ask which plant feeds which calibers, and how defenses shift sensors and interceptors when the next node is threatened. One factory gone doesn't end a war. It starts a supply clock. Each week lost in requalification and rerouting grows louder than any parade down a Capitol Avenue.